Hello everyone, myself Bhavani, Assistant Professor in IT Department, SMIT. Okay, now we are going to see about the database management system. In this, we are going to cover about the course outcome 2. Okay, now we are going to see about the second unit. See, in this, we will be going to see about design database using ER model and normalize the database. Like ER model means entity relationship model. Unit 2, database design. In this, first we are going to see about the entity in database design. Actually, it is a real world object or concept that can be clearly identified and about which data can be stored in a database. We are going to discuss how the data will be going to store in a database. This is the main concept. Like see, how it can be stored means first physical object. Like example, we can take it as students or groups or employees, and then a concept like courses, orders, and then account. Courses in the state, course name, like DBMS is also one of the course, okay, and then information technologies like that, and then an event in the sense transaction and then registrations. Moving on to type of entity, there are two types, strong entity and then weak entity. In strong entity, it has the own primary key. Actually, like variables, we can see SQL as primary key, composite key, foreign key, and all. Strong entity discuss about the it has own primary key. It can exist independently only and then represented by a single rectangle shape. Okay. Example C. Student is a table name gives the roll number is a primary key. Actually, they have been setting the roll number as a primary key to distinguish in the table. And then second type moving on to weak entity. Does not have a primary key of its own. Actually, weak entity does not have a primary key of its own. That is the major thing. Weak entity always depends upon the strong entity represented by a double rectangle. Okay. Example will be, see, dependent given depends on employee. In the table, we are going to use the dependent, it depends on the employee. Okay. And then what is ER diagram? It's an entity relationship diagram. It's a graphical representation of the structure of a database. It shows the actually diagram shows about the entities means object and then attributes, properties of entities, and then relationships, connection between entities, and then cardinality, how entities are related. Actually, ER diagram was introduced by Peter Chen in 1976. Now moving on to enhanced ER model. Enhanced ER model, see, actually entity relationship model is an extension of basic ER model. Actually, we need to know what is ER model. After that only we can go into the enhanced relationship model, entity relationship model. It adds advanced concept like inheritance and specialization to represent more complex database structure. Actually, it is the advanced concept of entity relationship model where we are going to discuss about the inheritance and specialization. Okay. It built upon the original ER model. Actually, ER model is introduced by Peter Chen. Okay. Main concept is they are subdivided into more concept. First, we are going to see about the superclass and subclasses. First, superclass would be general entity. Subclass, specialized entity derived from superclass. Subclass inherits attributes of superclass. This defines the subclass, okay? And then specialization. Process of dividing a superclass into subclass. This is the process of specialization. In specialization, we are going to use the top-down approach. It is represented by the triangle symbol. See, person means in person, like we can represent as a student or else as a teacher. Then moving on to generalization, third type. It's opposite of specialization. Quite opposite to specialization will be the generalization. Here we are going to use about the bottom up approach. And then combines similar entities into a higher level entity. Example C. Car plus bike, it gives us a vehicle. C. Commonly, it's known as vehicle and separately say as a car, four-wheeler or bike, two-wheeler. It's all commonly called as a vehicle, no? Then moving on to inheritance. See, subclass automatically inherits their attributes, relationship from superclass. Actually, inheritance, it gets the data from the parent class, no? That is called inheritance. Moving on to fifth one, disjoint and overlapping constant. Disjoint is nothing but entity belong to one only subclass. Okay. Only one subclass will be belong to disjoint entity. Example C, employee in the sense manager or engineer, not both. See, everyone can be named as employee, like only one, posting like manager or engineer. And then moving on to overlapping. Entity can belong to multiple subclasses. Example, person, see, student and employee. Moving on to total and partial participation, total specialization, and then partial specialization. Every superclass entity must belong to subclass. Partial specialization. Some superclass entities may not belong to any subclass. And then aggregation. It represents the relationship between relationships. One relationship and then represent the difference between the many relationships. Used when a relationship itself need to participate in another relationship. Example, employee works on project. Manager monitors works on relationship. Okay. Thank you.